Welcome back. Today's project will be a steady rest. The steady rest that came with the machine is way too small for my taste, so I'm gonna make one that's gonna use the exact same fingers as the old one, but the diameter will be larger, so it will fill in the gap between 120 millimeters and 63 millimeters. 63 is the maximum that all steady rest can achieve or can hold. But the new one is going to be much larger, so it will help me with bigger stock. I've chosen 125 millimeters because that will be more or less the size of stock that I can chuck up in this 3-jaw of mine. So yeah, I'm going to begin with the barrels. I've got 3 pieces of round stock that needs to be machined down to same length and 18 millimeter hole through the center. Think it will work. I know the barrel is a bit is 5 millimeters shorter than a piston, but unfortunately I ran out of stock, and this is the longest I can make it with what I've got. Okay, I've made myself a jig to align the barrels. It's bolted to a 4 millimeter aluminium plate. So what I'm gonna do is to use square tubing. I'm gonna make a double layered square tubing ring around it. And that's gonna form the frame of this of my steady rest. So yeah, that's a lot of work, so I'm not gonna show everything. So I'm just gonna give you a time-lapse view of what is happening. Okay, I'm gonna use this piece of plate here to copy this base here. Now what I've done is I've taken a piece of bar stock like this, which was flame cut, and I've cleaned them up off camera. So the idea is to mount the 2 blocks on the side here, cut a dovetail to the one, and yeah, this side will be a 5 degree angle, which will be used in conjunction with this wedge. Now this wedge has got a 60 degree taper on one side and a 5 degree taper on the other. So as you tighten it, it moves inwards. So that ensures that you get a proper grip. So yeah, that's my plan of action. I still need to clean the top and bottom of this plate. This is hardened steel. So I'm taking it very slowly on my mold, so I'm not going to film everything. I've already done the 2 sides. I just need to do the top and bottom. I'm taking around 0.2 millimeters at a time, and that's going slow. Right, see you in a bit. Okay, what I need to do here is drill 4 holes, 2 in each block. From the center line, 15 millimeter offset to the sides. In this case, this block will be 10 millimeters from this edge, and this one will be in the center line over the length. So 2 holes here, 15 millimeter each, offset from center, and smack bam in the middle. This one 10 millimeter offset from this edge here. So I'm going to use my homemade edge finder. Find center here, or edge, not center. To my X. Right, that's 10mm offset. Zero. Right. Find half of that. Okay, now that's my center line across and 10mm offset. So I'm going to move the incremental, zero my X, and now move to the other side. Zero my Y. And half of Y. Okay, that is dead center in this block here. So now I've got all my positions set, so I can run all the use or limit my tool changes in between. So if I do center drilling, I can do it on all 4 holes based on my incremental and absolute 0 points. Okay. To my 15mm offset. Okay, not needing to work on scribe lines and doing tool changes and everything to finish up one hole at a time. Resulted in having 4 holes done in about a third the time it would have taken to do one hole with all its tool changes to completion and move on to the next one. Okay, I'm cutting my first 60-degree taper in there. Okay, I've installed my two wedges. This one will be this, will mate with the 60-degree dovetail on the machine, and this side will form part of a wedge system with a little wedge that pulls down via a bolt. Now for that bolt I need to cut a 11 by 14 millimeter slot in here, because as the wedge goes down it will move forward because of this 10.8 degree angle here. So now I just need to cut the slot here. I didn't show you all the operations on this plate because it's just mundane operations, drilling holes and tapping and all this. So I'm just going to show you the slot and on this piece, and then the base of the steady rest will be done. Okay, I've installed a 10mm end mill. Now the hole that I've drilled is also 10mm, and that's with on purpose, because what I'm gonna do now is I'm gonna advance the table by 4mm, and by doing so I'm gonna do a plunge cut. That plunge cut is gonna cause deflection of the cutter, and because of that you need the end mill to be smaller than your actual hole size that you need. I'm gonna, after I've done the plunge cut, then I'm gonna mill out the sides to size. And the slot is done. Okay, here's a closer look at the plate. There's the 11 by 14 millimeter slot. My two wedges, one will form dovetail. And if you look at the base of the existing steady rest, they do align. Now this wedge here goes in like so, and when you tighten it, it moves in and it closes up the gap, so it takes up any slop that's in the system. So what I need to do now is to deburr these edges here and then bolt it to the table and mount my chuck and mount my steady rest head to the chuck, and then take measurements as to the risers so that I can weld those pieces, which I'm going to tack in now. I've aligned my top vise jaw to 90 degrees, so that should give me proper alignment here. And then I'm going to do the welding off camera because it's an awkward position, and I have covered the lathe bed as far as good as I could. Put a glove in the back and an apron me on top of the bed. So yeah, let me weld it up there, and then the next step after that will be to split it and then weld two tabs on both sides of it, and to reinforce this middle section here. I'm just going to put a little bit of a small piece of flat bar in here just to keep those two positions aligned. Okay, the welding is done. Now what happened is it went banana on me, so it bowed towards the side. So now I've placed it in the press while it's still hot, and I'm going to leave it like that so that it can cool down. Hopefully that bend will pull out. Okay, I've masked, unplugged all the surfaces I don't want painted, so I'm just going to give it a light coat of paint. This is not a tool that I can use every day, so that I need to give it a little bit of rust prevention. I've also got screws in the tapped holes so that no paint can go in there. I managed to squeeze out all the paint from that can, and I just made it to finish painting it. Okay, it's painted. Paint is still a little bit soft. The bottom edge is luckily not painted. Alright, here's the wedge. Let me just bring you closer there. Made with a 10-degree wedge that I've made on this end, and to the dovetail of the machine. I'm reusing the fingers from the old one. Along with the little grub screws. And these are locking grub screws. There, the build is done. I'm not going to split it. I've decided against that. I'll show you the reason why. Okay, any stock that can fit through that opening in that steady rest. If you can clear the tailstock here, and it will clear the tool post, and you can slide it in and align it with and chuck it up, and you can install it from either end, from this side or from this end. And this is the worst case scenario here, where it's as close as to the tailstock as it can go, with the table in between. Now I can't see myself turning anything longer than that. It's already more than half a meter, and yeah, if this opening just clears 125, so anything 125 and smaller will go in through there easily. Now I don't have a piece of stock that's 125, but it obviously makes sense that it will go through there and clear the tailstock. So I'm not going to split it. I think it's going to be more rigid, and as I said, I can install it from either end and it will fit. So I hope you enjoyed. This project was a long time coming. Now I made it this specifically for one purpose, and is for this piece of excavator pin, which I want to turn into a X-colored block. Now it didn't fit in my old steady rest, so this one it will fit. So until next time.